Right now, inside your body, something is happening that most people will never know about. Something so powerful that oncologists actually study it as a potential cancer treatment strategy. It doesn't cost a single dollar, it doesn't require a supplement, and it doesn't need a prescription. You trigger it simply by not eating for a specific amount of time. That process is called autophagy, and it is one of the most profound things your body is capable of doing. Most people think fasting is just a fancy word for skipping meals and cutting calories. That is the oldest, most misleading myth in the entire nutrition world. Your cells do not count calories when you stop eating. Your cells respond to time. And depending on how long you go without food, your body begins rebuilding itself at a level most people never experience. Different things happen at hour 4 than at hour 8. Different things happen at hour 12 than at hour 16. Your brain shifts its fuel source entirely. Your hormones reorganize themselves into a completely different configuration. Your fat starts burning in a way that is chemically and hormonally different from anything a calorie deficit alone can produce. In this script, I am breaking down the exact timeline of what happens inside your body from hour 0 all the way to hour 16 and beyond. Not what some influencer told you on Instagram, not what a supplement company wants you to believe, but what the actual research shows. By the time you finish reading this, you will know exactly what is happening inside your cells during a fast. You will know which hours matter the most. You will know which specific time window delivers the benefits you are actually after. But first, before we touch the timeline, you need to understand one foundational concept that changes everything. Your body runs on 2 completely separate energy systems. The first system runs on glucose, which is the sugar your body extracts from carbohydrates. The second system runs on fat. And here's the thing that almost nobody explains correctly. These 2 systems do not run simultaneously. They do not share the workload or take turns like 2 employees splitting a shift. Your body has a strict hierarchy, and glucose is always first in line. When you eat, glucose floods your bloodstream, and your pancreas releases insulin to manage it. Insulin's job is to shuttle that glucose into your muscles, your liver, and your cells as fast as possible. Your body loves glucose when it is available because it requires 0 processing and delivers energy immediately. Glucose is essentially premium jet fuel that your cells can ignite on the spot. But here's where most people get completely lost. Your body can only hold so much glucose at one time. Your liver stores glucose as glycogen, your muscles store glycogen, and once those tanks are full, the excess gets converted into fat and stored in your adipose tissue. When you stop eating, your body immediately taps into those glycogen stores first, not your fat. Your liver releases glycogen back into your bloodstream to keep your blood sugar stable. This glycogen buffer is the reason the first few hours of fasting are actually not that metabolically interesting. You are still running on glucose, just stored glucose instead of fresh glucose. The real question, the question that actually determines when the benefits start, is this: when do those glycogen stores finally run out? When does your body make the full switch to burning fat as its primary fuel? That is the timeline that matters. That is when the real transformation begins. You just finished your last meal, and your body is still completely in fed state. Your insulin is elevated, your blood glucose is relatively high, and your digestive system is working at full capacity. Your stomach is breaking food down, your small intestine is absorbing nutrients, and your pancreas is still pushing out insulin. Your hormones are sending one clear signal to your entire system: food is available, stay in storage mode. Insulin is high, growth hormone is suppressed, and your body has 0 intention of touching its fat reserves right now. This is actually how your body is supposed to work when food is abundant. It is not broken, it is doing exactly what it was designed to do. Here is the uncomfortable truth that most people in the fasting space refuse to acknowledge. During these first 4 hours, your body is literally not designed to burn fat efficiently. You just gave it fresh fuel, and it is using that fuel first, which means people who do 4-hour fasts thinking they are getting serious metabolic benefits are largely wasting their time. You might feel a twinge of hunger toward the end of this window, but that hunger is not a signal of metabolic starvation. It is a conditioned response, a habit loop your brain has built around the times you normally eat. Your ghrelin, the hunger hormone, starts rising because your brain is pattern matching against your eating schedule. Your body doesn't actually need food. Your nervous system just expects it. This is why breakfast skippers often stop feeling morning hunger after a couple of weeks of consistency. The habit loop breaks, the ghrelin response adjusts, and the psychological hunger simply disappears. What you eat before the fast also matters more than most people realize. A high carbohydrate meal before fasting will make the transition into hours 4 through 8 feel significantly harder. A balanced meal with solid protein and healthy fat will keep your energy stable and make the transition much smoother. This is where things start getting genuinely interesting, and for most beginners, this is also the hardest window. Your glycogen stores are starting to deplete in a meaningful way now. Your insulin is dropping noticeably, and your body is beginning to make a metabolic shift. This is not autophagy yet, but it is the gateway to everything that follows. Your liver is working harder than ever to maintain stable blood glucose levels by doing something remarkable called gluconeogenesis. Gluconeogenesis is the process of building brand new glucose molecules from non-carbohydrate sources like amino acids and glycerol from fat breakdown. Your liver is literally manufacturing glucose from your own body tissues to keep your brain functioning. This is why the protein you eat before fasting matters so much. If you ate high protein before your fast, your body uses dietary amino acids for gluconeogenesis instead of cannibalizing your muscle tissue. If you went into the fast on a low protein diet, your body will tear down muscle to get those amino acids, which is exactly the outcome you are trying to avoid. Fat burning is increasing noticeably during this window, but it is not the dominant fuel source yet. Your body is in transition, burning a blend of stored glucose and increasing amounts of fat simultaneously. But here's what's genuinely significant about this window that most fasting content misses entirely. Your insulin levels are now low enough that something important is starting to shift in your metabolic signaling. Chronically elevated insulin, which happens when people eat constantly throughout the day, causes your cells to become less and less responsive to insulin over time. This is insulin resistance, and it is the metabolic dysfunction that precedes type 2 diabetes and a long list of other health problems. When you fast and insulin drops, your cells start becoming more sensitive to insulin again. Your pancreas gets a genuine rest, your metabolic signaling improves, and this shows up in measurable ways in your blood work. Around hour 6, something else begins that doesn't get nearly enough attention. Your growth hormone levels start rising. Growth hormone is anabolic, meaning it builds and repairs things. It preserves muscle, it supports cellular recovery, and it helps your body maintain lean tissue even as you are burning fat. This is one of the reasons people often report feeling surprisingly good and energetic during fasts, rather than weak and depleted. But the growth hormone response is not automatic or identical for everyone. If you are sleep deprived, chronically stressed, or carrying high baseline cortisol, your growth hormone response to fasting is going to be blunted significantly. This is why fasting combined with quality sleep is dramatically more powerful than fasting on 5 hours of broken sleep. The hunger during this window peaks for most people, and hours 6 to 8 are often called the hunger curve for this reason. Your ghrelin is elevated, your stomach is sending empty signals, and psychologically you are fighting the habit of eating at familiar times. This is the hardest part of fasting for beginners, and it is completely survivable. Understanding that it peaks and then passes is one of the most important pieces of knowledge you can have going into a fast. Now we are getting somewhere. By this point, your glycogen stores are largely depleted, your insulin is genuinely low, and your body has made the full switch to running primarily on fat. Your adipose tissue, meaning your fat cells, are now breaking down triglycerides into glycerol and free fatty acids. Those free fatty acids get transported to your liver where they are converted into ketone bodies. Ketones are a completely different fuel source than glucose, and your brain, your heart, and your muscles can all run on them. Here's where things get fascinating from a neuroscience perspective. When your brain switches to ketones, it often functions more efficiently than it does on glucose. The mental fog many people experience in daily life is partly the result of inconsistent glucose availability and blood sugar fluctuations. Ketones deliver a steadier, cleaner energy to your neurons. The main ketone body responsible for this effect is called beta-hydroxybutyrate, and it fuels your brain through a completely different metabolic pathway than glucose. This pathway generates less oxidative stress and less free radical damage inside your mitochondria. You are literally producing brain energy with less cellular wear and tear. Your GABA production also increases when you are running on ketones. GABA is your brain's primary calming neurotransmitter, and it is the same system that anti-anxiety medications target. Your body produces more of it naturally when you're in ketosis, which is why fasting often produces a calm, focused mental state, rather than anxiety or agitation. Now, here's the part that makes this window genuinely special. Autophagy is accelerating significantly right now. Autophagy is your cell's built-in garbage disposal system. During fed state, when glucose and insulin are elevated, your cells are too busy processing incoming nutrients to bother with internal cleanup. But during fasting, especially from hour 8 onward, your cells activate cleanup pathways that remove damaged proteins, recycle dysfunctional organelles, prune old mitochondria, and replace them with new, healthier ones. This is where some of the most exciting longevity research connects to fasting. You are removing the cellular junk that accumulates over time and contributes to aging, chronic disease, and dysfunction at the most fundamental biological level. Growth hormone is now at elevated levels, often higher than what you experience during sleep. Cortisol is rising appropriately as part of your natural circadian rhythm, helping mobilize energy stores without becoming counterproductive. Norepinephrine is elevated, enhancing both fat burning and mental focus. By hour 10 to 12, most experienced fasters report feeling their best. The hunger has subsided, the mental clarity is strong, the body feels light and energetic, and the metabolic machinery is running at peak efficiency. This is not placebo and it is not willpower. It is your body operating exactly as it was designed to do when given adequate time without food. This is where the research gets genuinely compelling. Your body has been running on fat for hours now. Your ketone production is elevated and stable. Your autophagy is in full effect, and your metabolic state has reached its deepest and most optimized configuration. Fat oxidation is maximized in this window, meaning your body is pulling stored fat and converting it to energy at the highest rate possible. But something else happens around hour 14 that doesn't get nearly enough attention in mainstream fasting content. An incredibly important protein complex called mTOR starts to decrease substantially. mTOR senses when nutrients are available, and when activated, pushes your body toward growth and protein synthesis. When mTOR is inhibited, your body shifts its priority to cellular maintenance, repair, and recycling instead.
This pathway is one of the most studied in longevity research. In animal models, suppressing mTOR is consistently associated with extended lifespan. We cannot say definitively that this translates to human lifespan yet, but we can say that fasting activates the exact cellular machinery associated with longevity in every organism scientists have studied. That is not nothing. That is profound. Your immune system is also doing something remarkable in this window. Old dysfunctional white blood cells are being cleared out and replaced with newer, more capable ones. Some researchers describe this as an immune system reboot, and while the human research is still developing, the mechanism is real and the implications are significant. Around hour 15 to 16, something interesting happens with hunger. After the peak in hours 6 to 8, hunger has often decreased significantly by this point. Your body has fully adapted to fasting state, your ketone metabolism is stable, and the biological hunger signal becomes much quieter. The psychological craving for food might still be present, but the raw biological hunger has largely resolved. This second wind is one of the most motivating experiences for anyone new to extended fasting. You expect to feel worse the longer you go, and instead you feel better. Here's the truth that the extreme fasting community does not want to acknowledge. By hour 16, you have captured roughly 80% of the metabolic benefits that fasting has to offer.
The benefits do not scale linearly with time. The curve starts flattening dramatically after hour 16. Going from 16 to 24 hours adds some additional benefit, but not proportional to the extra time and effort invested. Cortisol starts rising more noticeably after hour 16, and beyond hour 18 to 20, your body begins increasing muscle protein breakdown for gluconeogenesis in a more significant way. The cost-benefit ratio starts shifting against you if you extend much further without a specific reason and solid preparation. This is the most important practical insight from the entire timeline. You do not need extreme fasting to get extraordinary results. A consistent 16 to 18-hour fast, done regularly, delivers the overwhelming majority of the metabolic, hormonal, and cellular benefits that fasting research points to. This is where most people quietly undo everything they just built. When you finish a fast, your insulin sensitivity is at its peak, your nutrient transporters are upregulated, and your digestive system is primed for absorption. Your body is genuinely ready to receive and use nutrients at maximum efficiency. If you break that fast with a massive insulin spike, refined carbohydrates, sugar, and processed food, you send your blood glucose and insulin rocketing upward and erase a significant portion of the insulin sensitivity you just spent 16 hours earning. The ideal way to break a fast is with protein-first, nutrient-dense food. Eggs, Greek yogurt, vegetables, nuts, quality animal protein. These foods deliver amino acids and micronutrients without triggering the aggressive insulin spike that processed carbohydrates cause. You are not just ending the fast, you are capitalizing on the most nutrient-receptive state your body enters all day. Treat that first meal as an investment, not a reward. Everything described in this timeline represents the general human response, but individual variation is enormous and it matters. Women do not respond to fasting identically to men because hormonal cycles create different cortisol and metabolic responses at different points in the month. During the luteal phase, when progesterone is high, extended fasting is often more physiologically stressful. During the follicular phase, fasting is typically better tolerated and more productive. If you are metabolically compromised, pre-diabetic, or insulin-resistant, your glycogen depletion timeline and your transition into fat burning may look different than what is described here. If you are a trained athlete, your metabolic flexibility may already be higher, meaning you shift into fat burning faster than a sedentary person. If you are stressed, sleep-deprived, or dealing with adrenal dysfunction, extended fasting will amplify cortisol in a way that becomes counterproductive. High stress plus extended fasting is not a health strategy, it is a stress multiplier. The best fasting protocol is not the most extreme one. It is the one that fits your biology, your life, and your goals consistently over time. Start with 14 hours if you are new to fasting, and let your body adapt over the first week. Extend to 16 hours once the hunger in hours 4 through 8 stops feeling overwhelming, which usually happens within 5 to 7 days of consistency. Eat whole foods, prioritize protein, and treat your eating window as intentionally as your fasting window. Fast 5 to 6 days per week rather than 7, giving your body occasional variation. Do not fast on days when your stress is high, your sleep was poor, or you are facing intense physical training. Give the practice at least 4 to 6 weeks before judging it because the psychological and metabolic adaptations compound gradually, and the best results come later, not in the first 2 weeks. The timeline is real, the mechanisms are real, and the benefits are real. Your body already has every system it needs to do everything described in this script. All you are doing is giving it the time and space to activate them. That is the entire secret.